What does a secret, almost guilty confession from Charles Darwin have to do with the food on your plate tonight? Well, today we're going to connect a secret that's over 150 years old to the future of our global food supply. And believe it or not, the story starts with something that felt like a murder. So back in 1844, Darwin wrote this in a private letter. Why so dramatic, right? Like confessing a murder. Because he'd figured out that species weren't fixed. They could change, they could evolve. And it turns out we humans had been proving his theory for thousands of years without even realizing we were running a massive experiment. I mean, just think about it. The entire history of farming, of agriculture, you can really see it as one giant planet-wide experiment. We weren't just passively growing food. Oh no, we were actively reshaping the very DNA of the plants all around us, pushing evolution into hyperdrive on a scale nature had never seen before. And this huge experiment is what we call domestication. And as you'll see, it turned out to be a classic double-edged sword. It gave us these incredible gifts, but it also created some really deep new vulnerabilities. Okay, check this out. Here are the results of our experiment, side by side. On the left, that's teosinte. It's the wild ancestor of corn, basically a scrawny grass with a few tiny rock-hard kernels. And on the right, that's our modern maize, or corn. We pick the plants with one big stalk, huge cobs, and soft kernels that actually stay put. It's a totally different plant, one that we designed for us. And this incredible transformation has a major consequence. Darwin himself pointed it out. Our creations, they are now completely and totally dependent on us. That corn on the cob is a powerhouse of productivity, for sure, but it would be completely helpless in the wild. It can't even spread its own seeds anymore. We've basically made our food our children. But that dependency, that isn't even the whole story. The very same process that gave us bigger, tastier, and more reliable crops also came with a really steep hidden price tag, a price that we're only now really starting to understand. And that hidden price, it has a name, the genetic bottleneck. So think of it this way. A wild plant has this huge, sprawling library of genetic information. But as we humans selected only the plants we liked, the ones with the biggest fruit or sweetest kernels, we were effectively throwing away most of that library. We kept just a few of our favorite books and tossed the rest. And the scale of this loss is, well, it's just staggering. We've lost something like 80% of the genetic diversity in maize compared to its ancestor. For wheat, it's around 85%. And for the common bean, it's a shocking 90%. We've basically traded resilience for productivity. We created these perfect thoroughbreds, but we lost the wild, hardy herd in the process. Now, this loss of diversity isn't just some abstract historical idea. It has created a massive problem for us today, a very real dilemma for the people whose job it is to secure the future of our food. And this right here, this is the heart of the problem. On one side, you have our modern elite crops. They're incredibly productive, super uniform, but that genetic uniformity makes them extremely vulnerable. A new disease or a sudden climate shift could be devastating. On the other side, you have their wild relatives. They're a treasure trove of genetic diversity and resilience, but they're low-yielding and totally unpredictable. So, this brings us to a really, really critical question. We've created these beautiful, productive agricultural masterpieces, but what happens when the canvas starts to tear? Have we accidentally thrown away the very genetic toolkit we need to fix them? Fortunately, scientists are not just sitting around. They're actually working on a pretty ingenious solution. It's not about choosing between the masterpiece and the toolkit. It's about building a bridge between them. And that bridge has a name: pre-breeding. So what on earth is pre-breeding? Well, you can think of it as the work of genetic translators. They go out into that huge, messy library of wild plant genetics, find one specific, useful gene, say for drought resistance, and then they carefully copy it over into a plant that a modern breeder can actually use. And the process is really methodical. First, they search. Scientists scan those wild relatives looking for these hidden genetic gems. Then they transfer just that one useful gene into a modern crop, creating what's called an intermediate version. And finally, they deliver this new improved material to breeders, who can then use it to create the next generation of supercrops. And I just love this metaphor because it hits the nail on the head. Pre-breeding isn't about just mashing the wild and the domesticated together. No, it's about precision. It's about finding that one single sentence, that one gene that can solve a huge problem, and making it available to everyone. But here's the thing, pre-breeding only works if we have that ancient library of wild genes to search through in the first place. And that brings us to the bigger picture, conservation. This isn't just about saving pretty plants. It's about creating a genetic insurance policy for the future of all of us. Now, when it comes to conservation, there are two main schools of thought. On one side, you have dynamic conservation. Its goal is to keep evolution going, allowing plants to keep adapting to their environment. On the other side, you've got static conservation, which is more about taking a snapshot, freezing a plant's genetic code in time for safekeeping. So how do those philosophies play out in the real world? Well, in situ, which just means on-site, happens on farms and out in the wild. That's dynamic conservation. It preserves the whole evolutionary dance. Then there's ex situ, or off-site. That's what happens in a gene bank or seed vault. That's static conservation, a vital backup, frozen in time. And here's the key takeaway. We absolutely need both. You can't just pick one. They're two sides of the same coin. On-farm conservation lets crops evolve new tricks in real time. Gene banks give us the ultimate safety net, a Fort Knox for seeds. You put them together and you get a really powerful, resilient system. And so we end right back where we started, with the code of life. From Darwin's private murder confession to the high-tech world of gene editing, the story is the same. The future of our food is written in the immense genetic library of its past. And the question for all of us is, are we being wise enough librarians to protect it?